Okay, so let's review our colligative properties for solutions. Vapor pressure lowering, boiling point elevation, and freezing point depression. The more solute you have in your solution, the greater the effect. So the more solute we have in our solution, the lower the vapor pressure, the higher the boiling point, and the lower the freezing point. So why is the vapor pressure lower for a solution? Let's look at these two diagrams here. This one is our solvent, say something like water, and this one is our solution. You can see the little pink dots here are the solute. And you can see that there is less vapor here in the solution compared to the pure solvent. That's because the solute particles interfere with the solvent evaporating. If we have fewer particles, we have lower pressure, lower vapor pressure. If the vapor pressure for a solution is lower, its boiling point is higher. Remember, in order for something to boil, the atmospheric pressure and the vapor pressure have to be equal. So if we already start lower with our vapor pressure for the solution, we have to heat it up until we can get the vapor pressure equal to the atmospheric pressure. This will occur at a higher temperature, and therefore the boiling point is higher. And for freezing point depression, all we're going to say is that the solute particles interfere with the liquid molecules going into the solid phase. If you remember, a solid has very organized particles, and a liquid is not very organized. So when going from a liquid to a solid, the particles have to get more organized. Solute particles interfere with that. So we're going to see a lower freezing point. On the phase diagram here, you can see the pure solvent compared to the solution. The solution has a lower freezing point, and that occurs here at this temperature, and a higher boiling point occurring here at this temperature. What we want to look at here next is these colligative properties and ionic compounds. So we're going to want to compare ionic compounds in solution to see which would maybe have the higher boiling point or the lower freezing point and so on. So we have to be able to think about how ionic compounds dissociate or break apart when they're put into water. And that's what we'll be talking about here, aqueous solutions of ionic compounds. So down below here, we're going to compare a solution of potassium chloride to a solution of sodium carbonate. Assuming everything else is equal, including concentration, we just want to think about the numbers of ions that are produced by these solutions. So potassium chloride, when you put it in water, it dissociates into potassium ions and chloride ions. And so you get 2 moles of ions. 1 mole of potassium ions, 1 mole of chloride ions. For sodium carbonate, you get 2 moles of sodium ions and 1 mole of carbonate ions. The polyatomic ion carbonate is covalently bonded. It does not break apart further into ions. So we get 3 moles of ions here. We have a different number of ions produced for each of these solutions, so we can compare them and pick out which one has the lower freezing point. The colligative property is freezing point depression. The more solute you have, or the more ions you have, the lower the freezing point will be. So we want to go with the solution that is sodium carbonate. There are more ions interfering with that freezing process, interfering with the liquid molecules going into the solid structured phase. Next, we'll compare lithium phosphate and copper chloride. We get 3 lithiums and 1 phosphate when lithium phosphate dissociates or breaks apart. So 4 moles of ions are produced. In copper 2 chloride, we get 1 mole of copper ions and 2 moles of chloride ions for a total of 3 moles of ions. Again, we have a difference in the number of ions that are produced. We want to talk about the lower boiling point. The colligative property is boiling point elevation. The more ions we have, the higher the boiling point will be. However, the question is about the lower boiling point. So we're not going to go for the higher number of ions here. We're going to go for the lower number of ions, which is our copper 2 chloride solution. In the final question, we're comparing sodium carbonate, which we already talked about in number 1, that produced 3 moles of ions, and copper 2 chloride solution in number 2, which also produced 3 moles of ions. So they produce the same number of ions when they go into solution. So with everything else being equal, neither one will have a lower vapor pressure.